All right, you're about to actually play the game and see what one of the things that matrices are used for. So here they have a system of equations used to actually do this by substitution method and addition method. Now you're going to use matrices. So they actually have something in here so that you're forced to use matrices. If you were like me, if I found a way to do it, I would do it the way I know how to do it. You cannot do that because you actually need to input certain things here that force you to do it correctly the way we want you to. So first you form the coefficient matrix. There's no messed up equations here that you have to simplify first. So the coefficients are just 4, 31, 215. Yours will be different than mine. Then I form what's called the right-hand side of the vector, which is 6, 56. It's this part right here. What's going on is you're now forming an equation with the coefficient matrix is A. The unknowns are x1 and x2. Look, if you do the matrix multiplication, 4, 2 dot x1, x2, that's 4 times x1 plus 2 times x2. That's the first left-hand side of the equation number 1. 31 times x1 plus 15 times x2 gives you the second row. And the 656 gives you the right-hand side. So it's just a reformulation of the entire system in terms of matrices. Or if I do it symbolically, this is what I have. A times x, where x is the vector x1, x2, is equal to b. This looks awfully like something that we had in baby algebra. And so the way you would do this in baby algebra is you would divide both sides by whatever's in front of the x. Do not do that here. That is something that makes people who have years of mathematics like myself upset. If I see a division by a matrix. You can't divide matrices. You must multiply by the inverse. And the reason is that multiplying by the inverse, it's matrix multiplication is not commutative. It doesn't even make sense if you divide. I'll point that out in a second. But I hit both sides on the left by an A inverse. And what that does is, as we know from the previous WebAssign, this is just the identity. And the identity times anything is itself. And the reason why I have to be careful is that A inverse is a 2 by 2 matrix and B is a 2 by 1 matrix, 2 rows, 1 column. So 2 rows, 1 column. And because of that, we have the matrix multiplication makes sense. Now, if you had put the A inverse on the other side, it wouldn't make sense. And even Mathematica is going to tell you it doesn't make sense. So what we're going to do now is go to Mathematica with this. So let's go there. I Rachel Rayed some of this. I put some of this cooked already. This is our problem. I'm going to insert the matrix A just like I did before. So just let me do it one more time so you can see. A is equal to parentheses, and I'm going to go insert table matrix new, and it's a 2 by 2 here. So I'm going to put 2 by 2, close that parenthesis, and then put in the matrix 4, 2, 31, 15. And then shift enter. Gives me that one. The B, let's do that again so you can see it. Doesn't hurt to see it again. So insert table matrix new. And this time I have 2 rows, 1 column. You mess up the row and the column here, all of the Mathematica is going to tell you that the matrix multiplication doesn't make sense. It's going to give you an error. 6, 56, 2 rows, 1 column. So I'm going to hit shift enter. That's my B. Then I'm going to calculate the inverse of the matrix A. Excuse me. So here we have the inverse of the matrix A. Now, if you go back and look at the question, the inverse of the matrix A was wanted. So here it is. I'm going to actually, if you look at minus 15 halves, it's really minus 7 fifths. So what's wanted here is A inverse, the formulation of it. 1, negative 2. So that you cannot have got without actually going through the calculations. So that's really nice. A inverse, and this is B. They wanted A inverse and B written here. And then you should get 11 and minus 19. And what that means is that x1 is equal to 11 and x2 is equal to minus 19. Let's go see what that looks like here. I'm multiplying A inverse times B. So let's do that. And I get, let's do the matrix form. 11 and minus 19, just like the solution on WebAssign. And what that means for us is that x1 is equal to 11 and x2 is equal to minus 19. So it gives you the solution to the system of those two equations. And so this is I would do this a few times and know how to do this well, because when you want to do this for real on, let's say, a WPR or something that you want to use it on for a project or a DLA, you don't want to be messing around with, oh, I don't know what the size of my matrices are. So this is fairly easy. It's not tough to do, but I'd at least do it 3 to 4 times before I'd be confident that I can do this right.